Welcome to all in today's video lecture. Today we are going to show you the response surface methodology using Minitab. To begin with these things, let me introduce myself. I am Shobhan Sarkar, the PhD student in the Department of Industrial and Systems Engineering, IIT Kharagpur, and also the teaching assistant of the subject of design and analysis of experiments. So, to begin with these things, let us have a glance to the contents page. Here the response surface methodology with a small example has been given and then references has been produced. So, coming back to the example, as we can see, and we have gone through it many times in the normal video lectures. So, this example has been given for your clear understanding. The main focus of this video lecture is to demonstrate how to use Minitab in order to analyze the results, experimental results of any situations. So, situation is, the problem statement is given: a chemical engineer is interested in determining the operating conditions that maximize the yield of process, that is this. Two controllable variables influence process yield, that is the reaction time and the reaction pressure, reaction temperature, that is given here. So, 9 observations are made. So, now you can see, first this is our data set. So, initially we have to copy and paste the data set into one Excel file, this one. So, from this we have to copy it and paste into the Minitab window. Next, coming to the point of stat, under the stat DOE option is available. So, as we are analyzing through the response surface, so response surface under the DOE tab we have to select, and then also under the response surface we have to first define the custom response surface design. So, reaction time and reaction temperature have been selected as continuous factors. After that, low and high options are selected. Here factor A and factor B are given, their corresponding name have also been provided. Their low value and high value are also given corresponding to each of the factors A and B. As we can see from the data set, we can see that for factor A, the low value and the high value are 30 and 40 respectively. You can see 30, 30, 40, 40, 35, 35, 35, 35, 35. So, low value is 30, maximum is 40. Similarly, for B, factor B, that is reaction temperature, the minimum value and the maximum value are set as 150 and 160 respectively. So, once we have checked it and set it into this window and click it OK. Coming to the design, this design has been given so many options. First one, standard order column, order by the data, run order column, order by the data, point type column, it is not required at all, blocks, we are not doing any type of blocks here. So, no blocks, click OK, then also click OK. So, here we can see the new 4 columns are also added with the initial 4 columns, that is they are standard order, run order, blocks and point type. Now, after getting this data, you have to go back to the stat DOE response surface, then analyze response surface design. Here we have to select the yield, that means y variable, the response variable. Click terms. Here we can easily select either linear plus squares or linear plus interactions or full quadratic. If you click the full quadratic as per our requirements and the situation. We can see the selected terms are A B, AA, BB and AB, main factors, then A square terms, BB and their interaction effects. Click OK. Then click the options. For weight, we are not going to do any insert any weights. Confidence level is 95, two sided type of confidence interval, no transformation is required. So, click OK. Stepwise, it is also not required anything. Then going to the graphs, regular graphs, under the residual plots click 4 in 1s, and it is very convenient to observe all the plots in a same window. It will be helpful for 4 in 1, or you can opt for also the individual plots if you want to get only histogram, not others, or even you can get, if you want to get the 2 of 4 or 3 of 4, then you can easily customize your requirements by selecting your required number of plots. Here we need all 4 plots in a same window. So, click 4 in 1. So, click OK. Then results, simple tables, then storage, the same thing, the Cook's distance, leverages, residuals, feeds, coefficient, design matrix which might be of interest, then this can be easily inserted, but for the time being I am not going to show you and inserting anything. So, I leave it blank, nothing. So, click it OK. So, now click OK, and all the 4 plots, as we have told you earlier, have been generated in the same window. So, residual versus percentage, normal probability plot, fitted value by the residual, observation order by residual, and residual versus frequency, all plots are given, all plots are produced here. Coming to this main window, we can see the response surface regression, yield versus reaction time, reaction temperature, analysis of variance, ANOVA table are produced, or model parameter model things for degrees of freedom 4, sum of square, adjusted sum of square, at the mean square, F value, P value, as already we know all these things. So, I am not going to show you anything and interpreting in depth. So, this is a linear for the reaction time, the reaction temperature, for the square terms that means the reaction time and reaction time, two-way interaction reaction time versus and reaction temperature, error rate, then total. This is a standard analysis of variance table, and they are corresponding sum of squares, mean squares, degrees of freedom, F value, and their corresponding P values. If any value for the P being less than 0.05 are considered very significant one. So, in that case 1, 2, 3, that means reaction time, reaction temperature and the model are very important and significant in this respect. Coming to the coefficient, there is a constant term 40.46 for the reaction time, for the reaction temperature, then reaction time and reaction time, reaction time and reaction temperature, these all coefficients are recorded. And this is the regression equation, yield equal to 17.8 plus 0.408 reaction time plus 0.100 reaction temperature minus 0.0014 reaction time into reaction time minus 0.001 reaction time into reaction temperature. This is the our main focus is to get the reaction equations from the experimental data using response surface methodology, and here is the output results. Now, I have made it smaller. Now, coming to the DOE, response surface and contour plot. Now, we are going to plot the contour plot. How to do these things? So, once we click the contour plot, the options are coming. As a response one, we have selected is the yield, x axis I have set it reaction time, y axis reaction temperature, or even you can alter these things as x axis as reaction temperature, y axis as reaction time. Also we can do these things. Then contours, then options, nothing to do with it, the view the model, it is okay, then click OK. So, here is the contour plot, it is generated, where it is a reaction time x axis, y axis is reaction temperature, and this is the contour plot. This is a contour plot of yield versus reaction time, reaction temperature versus and reaction time. You can see these things, and subsequently you will be able to interpret these things. Similarly, if you want to generate the response plot, then you have to click the 3D surface plot. Here the wireframe is selected, click OK. Similarly, you have to put the z variables, as I have selected a z variable as yield as a z variable, reaction time is a y variable, and reaction temperature as x variable. Then surface option, it is a distance method we are selecting. One may opt for the Acumulus polynomial method, the result will be varied accordingly according to your choice. Distance power is 2, it's okay. Then scale, nothing to do with it. Then click the labels. Again, if you want to add something with it as the title, subtitle 2, footnote, you may add for your convenience. This is a data label, data display, symbols, surface, symbols, project lines, then data options, all rows, I have clicked it, click OK and then click OK. Here you can see this is a 3D graph tool, this is a surface plot are generated, where reaction time is here, reaction temperature x and y z is vertical axis is representing the yield. Here is the surface plot. Now, coming back to the point of the PPT, similar to this process the presentation has been made for your convenience to follow and to practice in Minitab. The step 1, step 2, step 3, adding the high and low value for the factors with coded and uncoded options. Step 3, again this is a the data set is given from which we can easily set as low and high value. Then customize the design, step 4. Then 5, step 5 is new attributes are added with the final data set. Then step 6 is analyze the response surface design. Step 7 is select the response, y yield is considered as a response here. Then customization of designs, it is a completely user specific. Here we have shown you that the following terms is linear, one may opt for the linear plus square terms or quadratic terms. I have selected here the quadratic terms, that is why result will be different from this the results that of the this particular PPT. Then these options would come up and all the snapshots are given for your convenience. Then results window. This is the results window are coming. This is a four plots are given, are produced. Here is the data set. This is a 4 plots as we have discussed, and here is the ANOVA table, model summary, regression coefficient, regression equations. We can see here the regression equation we have generated, and it is the ANOVA table. From this we can easily interpret which factor is very important, that means significant, which is not, we can easily interpret. We can also observe the coefficient of constant term, the reaction time, the reaction temperature. So, generation of the control plot we have already discussed and also demonstrated you. Here is the output of the control plot. Now, here is the response surface generation. So, last point is the select the factorial plot. So, to do the factorial plot, coming back to the Minitab, coming to the stat, DOE, response surface, then factorial plots, this option is there. Click it and you have to set response as yield, and then this is a selected these variables, then options, if you want to add something you can add. These are the graph plots, okay. Then view models, again this is a response is yield, so click it ok. So, you can see this is the interaction plots are given, the main interaction plots are given. So, this is a mean of yield, this is a reaction time, this is a reaction temperature, and again this is a mean of yield. So, here the yield is from low to high, reaction time is low to high 30 to 40, and mean of yield is 39.5 to 41.25. So, as the reaction time increases, the mean of yield also increasing. Similarly, we can see 150 to 160, this scale is given for the reaction temperature, and the mean of yield remains same. We can also experience the same kind of behavior of the graph, that is, as it is increasing, the mean of yield is also increasing, but it is too steep in nature, and whereas it is comparatively flat than this one. Coming to the interaction plot, here you can see the reaction time and the reaction term, and then reaction temperature. Here the reaction temperature and reaction time is given, and the mean of yield. In a same plot it is given. So, through this graph and the tables, and that is ANOVA tables, you can easily interpret which variables are important, what is the equations ultimately you are getting. You can see which regression equation will be, how you can get the factor plots, how you can generate the surface plot in response surface methodology, and how you can get the contour plots throughout these experiments. Through the following this procedure, which are nicely illustrated from the beginning of the slide, one may easily carry out the experiments using Minitab environment. So, using these things ultimately you will get this type of graph, and this has been given in a same window to visualize how you can interpret through Minitab software. This is a contour plot, this is a surface plot, and this is a factor effects, main factor effects. By choosing differently, I have also shown to you the interaction effects with mean of field, but here I have not selected these things. This is completely depends on users requirement. As you require it, you can also generate many more graphs using this Minitab software. It will be really helpful for this analysis purpose, and for other statistical analysis purpose is really very useful. So, this is the final results using this Minitab for response surface methodology. If you have any further queries or questions how to use the Minitab for experimenting in design analysis by experiments or other purpose, if you have any queries, any doubts, you can ask me and we can discuss with us. We will try our level best to help you out and give you, we will try to provide you the required solutions, so that you can get the best out of this particular software Minitab to fulfill your purpose ultimately. Thank you.